Today, we're going to talk about hypotheses and statistical significance. So let's start with hypotheses. And just so you know, hypotheses, spelled S-E-S, that's just the plural of hypothesis, which is singular. So an hypothesis then is a statement of a relationship between two or more variables. This means that you are making a statement saying how you think your two variables are going to be related. Or you could have more, but sort of the most basic is we're looking at a relationship between two variables, our independent variable and our dependent variable. So importantly, when you're writing an hypothesis or critiquing a hypothesis that already is out there, there should be a specific testable statement. So it's something to say that, X is related to Y, and so you're going to test to see if that hypothesis is correct. And it forms the logical basis of inferential statistics because, remember, in inferential statistics, it's all about being able to infer from what we have to a larger population. So you use the sampling error distribution to basically come up with whether there is no difference or a real difference, which we're going to talk about when we talk about statistical significance. But this also is about it takes into account our confidence that we have in whether we see an actual relationship between our variables or not. And that comes from whether we think it's a true difference or just a result of error. And so if it is a true difference, and it goes sort of in line with what our hypothesis is, then we can say our hypothesis is correct. So there are two different types of, or major types of hypotheses. We have our null hypothesis and our alternative hypothesis. So the null hypothesis says there is no relationship between your variables. So this would be a zero association. So a null hypothesis basically is the starting point that if you can't get any evidence to the contrary, the null hypothesis is what you default to. So the alternative hypothesis is kind of like the real hypothesis, what you really are trying to determine, or the relationship you really think exists between your variables. So it's that attempt to explain those real differences. So you're saying one variable affects another in some predictable way. So the alternative hypothesis is typically the one that you would see as sort of the main. This is the focus point. This is what we're trying to determine. But the null hypothesis isn't always stated. But if you look at, say, research studies in journals and things like that, the null hypothesis isn't always stated, but it's inferred as being sort of if we can't prove our main hypothesis, which would be the alternative hypothesis, then you default to that null hypothesis. So it's always there, even if it's not stated. So a little bit more about that null hypothesis. So the designation of that is you would put an H with a little subscript 0. And so the null hypothesis then basically says that, so it comes from the idea that because there's error, remember, anytime we do research of any kind, anytime we're running any kind of statistics, there's always error of some kind. There's measurement error, there's human error, and there's a whole bunch of other types of error. So because there's always error involved, it's unlikely that when you're measuring a relationship between two variables that are actually not related. So in reality, if we could sort of just know that two variables are not related, if you're going to measure them and you're going to see if there's a relationship between them, they probably still won't produce an actual perfect zero association. Even if they're totally unrelated, they still won't have a perfect zero because of error. So even if they're totally, one has nothing to do with the other, but you measure to see if there's a relationship between them, you might get sort of a correlation, let's say, of like 0.1 or 0.2 or 0.3 or even as high as 0.5 or 0.6 or whatever, depending on what you're doing. But that alone doesn't necessarily mean that the variables are related, because that just could be because of random error. We had some amount of relationship or correlation there. So it doesn't necessarily mean that the variables are really, in reality, actually related. So, and this is all because of error. So the null hypothesis then represents the idea that any non-zero result is just because of random error. So if your null hypothesis is true, then it doesn't mean you're going to have a zero association. It just means any association you have is just because of error. And it isn't enough to reach the standard to say that there's actually something real going on here. So that's kind of what the null hypothesis represents. That, yeah, you might see some relationship, you might see some numbers that are not just strictly zero, but that's just random error. And that's what the null hypothesis is, that there's no relationship between the variables. What you're seeing is just error. So then the alternative hypothesis is kind of our real hypothesis, the one we really want to focus on. And so this is designated as H with subscript A if you only have one. But if you have multiple alternative hypotheses, then it would be H subscript 1, 2, 3, 4, 5, however many you have. But if you just have the one, then you would use H subscript A. So this is the one where we have to state, we're saying that this variable is going to affect this other variable. And so there are two ways you can do this. So you can have an alternative hypothesis that is two-tailed, which is kind of open. It's non-directional. We don't know how the variables are going to be related. We don't even have a guess as to how the variables are going to be related. We just think they are, and we're just going to see what happens. So this is in an alternative hypothesis that's two-tailed. You wouldn't specify how the independent variable affects the dependent variable, just that some relationship is going to exist. And so it's called two-tailed because you're examining both tails of that normal curve. Remember when we talked about the normal curve, it has those two tails on the end, that once it gets far enough out into those tails, then that's where you can start to say, this is not just because of random error, this is because of something real going on here. So it's called two-tailed because you could be out in either tail, but because you don't know which way it's going to go. So a two-tailed is a non-directional hypothesis. But you could also have a one-tailed, and this is typically more common because usually if you have an hypothesis, it comes from sort of what you've seen in the literature or what theory might have to say, and so you have an idea as to what direction it's going to go. And so this is sort of the more common. This is the one-tailed or directional, and so that means in the hypothesis it's going to say how the independent variable affects the dependent variable. And so it's called one-tailed because it's only one tail of that normal curve, because you know if there's a relationship that's going to be significant, it's going to be on this side. It's going to be because it increases it or it decreases it or whatever. So an example of a two-tailed alternative hypothesis might be gender affects delinquency. You don't know if males or females or non-binary, you don't know anything about how it's going to relate to delinquency. You just think there's going to be an effect. That would be two-tailed. You don't know which way it's going to go. One-tailed might be increased education results in decreased criminality. So we think that as education goes up, as somebody gets more educated, their likelihood of criminality is going to go down. We think that that's the direction it's going to go. If we take sort of a complete example, if we were to have a research question that says, does gang membership affect parole recidivism? All right, so does being in a gang affect the likelihood that somebody is going to commit a crime or sort of breach their parole? All right, so our null hypothesis would be gang membership does not affect parole recidivism. That'd be it, that there's just no effect. There's no relationship. A two-tailed alternative hypothesis would be gang membership affects parole recidivism. So there's an effect. We don't know how it's going to relate, but we think there's going to be an effect. And a one-tailed directional alternative hypothesis would be, might be that gang members have higher rates of recidivism than non-gang parolees. Then that would be, we're saying that people being part of a gang is going to increase their likelihood of breaching their parole. So that's kind of how you would work through. You would have your research question, you would have your null hypothesis, and then you wouldn't have both two-tailed and one-tailed. You would pick based on how much you know and what the literature says. But that would kind of be the steps that you would go through to come up with your research question, which then brings you your null hypothesis, which then brings you your alternative hypothesis, whether it's one-tailed or two-tailed. And again, you could have multiple hypotheses, like maybe we want to throw something about age in there and say that young gang members have higher recidivism rates than young non-gang parolees, but maybe once they're older, there's not much of an effect or something like that. So you could have multiple hypotheses, multiple alternative hypotheses, but sort of the most basic is you've got your research question, you've got your null hypothesis, and then you have either a one-tailed alternative hypothesis or a two-tailed alternative hypothesis. All right, so that's it. So that's it for just hypotheses. And so then watch the next one for statistical significance.